sequence question. This is the first, second, and third term of an arithmetic progression are A, 3 over 2A, and B respectively, where A and B are positive constants. The first, second, third terms of the GP, geometric progression, are A, 18, and B plus 3 respectively. Find the values of A and B. So if you're just giving um, letters and numbers and expressions, there's no way of doing anything you really know with a sequence. So one thing that is very important in questions like this, where it seems like there's nothing you can do with the numbers they're giving to you, is to recognize that the defining factor for an AP is that it has a common difference. That's a difference that is common. As for a GP, it's the common ratio. So for the AP, you know the common difference is something that defines it. So you can say to get the common difference of an AP. So let me just put for an AP here. So for the AP, as the arithmetic progression, for the AP, we know that the common difference D is the second term minus the first term. So let's use T2, T and the subscript 2 minus T1. It is also the third term minus the second term. It would also be the third term minus the second term. So that's T3 minus T2. This is for the AP, T3 minus T2. Now, with this in mind, we can get an expression for the common difference. We know the second term of the AP is 3 over 2A and the first term is A. So we can say the common difference for the AP is 3 over 2A, 3 over 2A minus A, 3 over 2A minus A. Also, we know that for this same AP, the common difference could also be B minus 3 over 2A. That's T3 minus T2. So since they are the same, we could say they are equal. So T2 minus T1 is equal to T3 minus T2. So 3 over 2A minus A is equal to D minus 3 over 2A. B minus 3 over 2A. Now let's rearrange and get an expression. So if we rearrange this, we get 2A is equal to B. So we bring minus 3 over 2 to this side, it becomes 3. It becomes 3 over 2A minus A plus 3 over 2A. That will just give us 3A. So let's, instead of me just saying it out, I was just thinking I was going to jump straight into writing the answer, but I want you to see how it is. Since they are fractions, then it may confuse you. So that would be 3 over 2A. So before I write this minus A, I want to bring this minus 3 over 2A up to this side to make it a positive. So plus 3 over 2A plus 3 over 2A minus A is equal to B. So 3 over 2A plus 3 over 2A. 3 over 2A is the same thing as 1.5A, like you know. 1.5A plus 1.5A, that's 1.5 plus 1.5 is 3. So this is 3A. 3A minus A is 2A. So let's just go straight into writing 2A. I don't need to write 3A minus A again for writing 2A. So 2A is equal to B. This is an expression we've gotten from the AP. Now we can get another expression with the GP. But this time around, we'll be dealing with the common ratio. So let's put GP here, geometric progression. So for the GP, common ratio R is equal to the second term divided by the first term, C2 over T1. It is also the same thing as T3 over T2. It's also the same thing. So T2 is 18. So that means the common ratio 18 is 18 over 18 over A. So I put the over A like this. 18 over A. And also the common ratio is still b plus 3 over 18 is equal to b plus 3 over 18 because that's also the common ratio and the common ratios must be the same. If not, it's not the same, then it's not a GP, not a geometric progression. So is equal to b plus 3 over 18. Now at this point, you can just cross multiply to get another expression. So we'll do this times this first. So we get a times everything here will give us a times b is ab. So it will be ab plus 3a, ab plus 3a is equal to, then we'll do the multiply 18 by 18 again. 18 by 18 is 324. So is equal to 324. So this is our second expression. So this is our first expression. This here is our first expression. 2a is equal to b. This here is our second expression. ab plus 3 is equal to 324. Now we can substitute for b into this equation here. So let's do that just beside it. I don't want to have to keep scrolling away. That's why I'm just drawing the line. I'm doing it in the same space. So b is equal to 2a. So I replace b with 2a, and then I get a times 2a plus 3a is equal to 324. So a times 2 will give us 2a squared. So 2a squared plus 3a. So plus 3a. Then instead of making it equal to 25, equal to 325, it just be 324 to this left hand side to make it a quadratic equation. Minus 324 is equal to 0. So now that you have this quadratic equation, you can put it in your calculator and then solve for a. When you put it in your calculator to solve for a, you get two answers for a. You get a to be minus 27 over 2, and you also get a to be 12. But if you recall, the question says a and b are positive constants. So we know a is 12. So we can just say a is 12, and then we can find we know a is actually 12, not 27 minus 27 over 2. So if a is 12, then and we know 2a is b, so that means 2 times 12 is b. So that means b is 24. So a is 12 and b is 20.